Imagine this, an asteroid the size of a building racing toward Earth with no warning at all. On a cold February morning in 2013, a blinding flash exploded over Chelyabinsk, Russia. The asteroid hit our atmosphere at 67,000 kilometers per hour and detonated 23 kilometers above the ground.
Pluto, the most famous dwarf planet, small yet complex, with a thin atmosphere and a moon nearly half its size.
It should be visible by now. How could we miss it?
I don't know, Director. The screens are completely blank.
Now imagine something far worse. A mountain-sized asteroid drifting into a collision path with Earth. To understand how we respond, we go inside one of the world's most important asteroid hunting facilities. It's 3 a.m. at the Catalina Sky Survey. Scientists scan the sky piece by piece. Suddenly, a point of light moves faster than anything else on screen. Confirmation arrives. A new asteroid. Big, unknown, and real. We've found over 39,000 near-Earth asteroids, but millions more are still undetected. Earth is constantly bombarded by space rocks. Most burn up, but not all. A 50-meter asteroid flattened 80 million trees in Siberia back in 1908. A 400-meter asteroid could wipe out an entire country. A kilometer-wide one could change the world forever. In our scenario, the new asteroid is named 2034 LV1, but scientists call it Soteria. Radar reveals it's 400 meters wide, made of iron and nickel, traveling at 75,000 kilometers per hour. At first, the impact chances are 2%, then 15%, then 40%. Finally, the probability stabilizes at 90%. Soteria will hit Earth in October 2041. Humanity now has 6 years to stop it. The UN activates emergency planetary defense teams, uniting global space agencies. Option 1. Do nothing. Hope it misses. Obviously, not a real option. Option 2. Kinetic impactor. Hit it with a spacecraft to nudge it off course. This method already worked in real life. NASA's DART mission successfully changed an asteroid's orbit. Option 3. Use a nuclear device to vaporize part of the surface, pushing it off course. The world chooses the kinetic impactor. 2 massive spacecraft begin construction. In 2037, the mission launches. The whole world watches. 5 months later, humanity takes its shot.
Trajectory adjusting right. Looks like we're in for some turbulence.
Direct impact. A flash, a cloud of debris erupting from the surface. The orbital change is tiny, but enough. Soteria will miss Earth. In 2041, the asteroid passes safely. Humanity wins, and if the real day comes, we'll be ready.